All right, let's take a look at our lesson on polynomial functions. So polynomial functions are just an extension of what we have been working on, which are quadratics. So we're just going to take that to the next level. Polynomial, we're talking about, in this particular case, a polynomial on one variable would look like this, where we have, these are called terms, these things that are separated by pluses and minuses. So we have arrangement of terms where the very largest exponent, we would call it the degree of the polynomial. So if our polynomial is in standard form, that means that the exponents are in descending order. Then once we get it in that order, in descending order, we would look at the first term, which would of course have the highest exponent, and that would be the degree. So if the highest exponent was 5, this would be a 5th degree polynomial. Something else interesting, another vocabulary word we need to be aware of is leading coefficient. Leading coefficient. The leading coefficient is the number in front of the largest exponent. So this is an important concept as well. We just need to know if somebody asks you what the leading coefficient of a polynomial is, you should be able to know what that means and be able to say that. All right, so let's talk about some other vocabulary words. We have some vocabulary words that have to do with the number of terms in a polynomial. So a one-termed polynomial is called a monomial. If there are 2 terms in it, it's called a binomial. 3 terms is called a trinomial. And 4 plus, we don't typically have a name for 4 plus, we just call that a polynomial. We don't have a special name for that. All right, so that is an overview of polynomials in general. So now let's work on some specifics. These first examples have to do with function notation and finding particular combinations of these 2 functions. I have a function, the name of this one is g, and the name of this one is j. And so on this first problem, part A, they want us to take 5 and multiply that times g of 2, and then they want us to subtract j of -1 from that. So we have several things to accomplish. So let's start. So I want to have a 5 here outside. Then I want g of 2. So I'm going to take the function called g, and I'm going to put a 2, just open up a spot where the x is, and just slide a 2 right in there. So now I have 5 times g of 2 minus, now I'm going to choose the function called j, and I'm going to, again, the whole thing is being subtracted, so I need to be sure to remember to put a parenthesis there. So I'm going to insert a -1 in place of each x. Again, I open up a little spot where the x is and just insert the -1. Okay. There we go. So we have a -1 inserted for all of those x's in j. So let's start working that out. Let's do our arithmetic. Yay! So let's see, I have a 2 cubed, so that would be 8. So -8. 2 times 2 is 4, minus 3. And then let's deal with what's inside the parentheses. -1 squared is 1. -6 times a -1 is a +6. So there we go. We're working on that. So let's continue with our arithmetic. Let's see. -8 plus 4 is a -4 minus 3 is a -7. Then I have minus 1 plus 6 is 7. Okay, so if you probably remember, I'm going to pause here for just a moment, make sure everything that I'm doing is following order of operations, PEMDAS, parentheses, exponents, multiplying and dividing together in order from left to right, adding, subtracting in order together from left to right. So that's the process I've been using as I'm working through here. Now we have the choice of multiplying or subtracting. And of course we're going to have to do the multiplying first. So I have negative 35 minus 7. And then I finish that up with subtraction. Negative 35 minus 7 is a negative 42. And there is our answer to that part A. All right, so let's look at part B. They just want us to take J and insert a negative 3a everywhere there is an x. So here we go. So negative 3a is in place of the x. Negative 3a. And then we're going to work on our order of operations. So parentheses. The parentheses that I have here are just, there's nothing inside the parentheses to do. They just represent multiplication, basically, or exponents. Here I'm negative 3a squared. That would take us to exponents. So if you recall from your work with exponents, when I have two like quantities, negative 3a, both raised to the second power, basically it means I have to raise each of them to the second power. Okay, now I am being real specific and writing that out just in case you have forgotten your order of operations. I'm sure no one has. I'm sure we haven't done that. So now we'll work on that in just a moment. So I have a negative 6, or we can think of it as plus a negative 6 times a negative 3a. That would give me, what, a positive 18a. Okay, so let's go back here. So keep working down. Negative 3 times negative 3 is 9. A times a is a squared plus 18a. And that's basically it. That's all we can do. We can't combine those together because those aren't like terms. All right, great. Let's keep moving on. We have another little configuration they want us to do. So we have a different function. This one is called f. And let's see, let's just jump in. So function notation, I'm supposed to take this quantity 3c minus 4 and replace all the x's in f with it. That's what this is telling me to do. So let's do that. So I have 3c minus 4 squared plus 2 times 3c minus 4 minus 3. I have just written down this first piece. Okay, minus. So I've got 5 times f of c. This is just telling me to replace all of the x's with a c. Okay, we can do that. No problem. And that is my first go around. I'm just substituting in those quantities in place of x in that function called f. All right, so we've got some fun ahead of us. Yay, fun algebra. This 3c minus 4 squared, I hope nobody listening thinks that I can just distribute the squared across there. That's no, no, no. That means I have 2 of those. Okay, good. So I'm just writing it out. I'm going to go ahead. Let's see what we have here. Oh, that's a messy c, isn't it? I'm going to go ahead and distribute this 2 right here as I'm going along. So that would be plus 6c minus 8 minus 3. Okay, good. Got a little work done there. So let's go ahead and distribute the 5. So I have 5c squared plus 10c minus 15. Okay, making some headway. So we're going to have to FOIL the 3c minus 4 times the 3c minus 4. So let's FOIL that. So first, 3c times 3c is 9c squared. Outside, negative 3 times 4 is 12. Inside, negative 4 times 3 is negative 12 plus 16. Okay, great. Plus 6c. I'm going to go ahead and do minus 8 minus 3 is a negative 11. And now let's just distribute that negative inside this last parenthesis so we can lift the parenthesis. So minus 5c squared minus 10c plus 15. Whew, that's quite a bit. Now our job is to combine like terms. What I'm going to do is put put a little colors. I'm just going to do color coding. Here's my c squareds. I'm going to combine those together in just a moment. Let's see my plain old c's. I'll do in light blue. Okay, great. I'll combine those together in just a moment. And then my regular old numbers, I'll put those in green. Okay, great. So that's what our task is. We got a lot going on there. Okay, so let's go descending order. So let's work on the largest exponent first, which is c squared. So 9c squared minus 5c squared is 4c squared. Great, done with the pink ones. Let's work on the light blue ones. Let's see, negative 12 minus 12 is negative 24. Minus or plus 6 would be what? Of course I have to write down because I can't keep that in my head. Minus 24c. Then we've got plus 6 minus, so minus 4c. Now let's work on the green ones. So 16 minus 11 is 5, plus 15 is 20. So, because I can't do numbers in my head, I don't know, y'all probably can. I needed to do the c's in 2 steps. Whew, there we go. There's that one. That one was intense, wasn't it? All right, so now let's go ahead and go to our second page and practice some more things with polynomials. So we just worked on working with polynomials and function notation. Now let's do some just operations. Let's just add, subtract, just do some stuff like that. So on number 1, it's basically, okay, where did you go, little guy? Yes, it likes to go crazy sometimes. Come back. Well, isn't this fun? Okay. Here we go, back at it. Come on, you can do it. Focus in. Oh, geez, Louise. Pardon the technical difficulties. Let me get this fixed up here. Okay. Now let's see if it'll behave. I don't know. Keep your fingers crossed, guys. It's just acting crazy. Okay. Now, let's hope it stays and behaves itself. I don't know. I can't make any promises. All right. So I know those of you that have these, you know, that happens sometimes. Okay. So on number 1, we just have, and let's just practice our vocabulary, we have a trinomial plus a trinomial. And we're just going to combine like terms, you know, the ones that are squared, you know, we're going to add those together. The ones that are single to the first power, we'll add those together, and then the numbers. So just pretty straightforward, not too bad. That would be what, 7x squared minus x minus 5. Okay. Good. On number 2, a little bit more challenging. We're not just adding, we're subtracting, and that always, oh my goodness gracious, always can cause trouble. Forgetting those little negatives can really mess us up. So we need to really focus on knowing that we've got to distribute the negative to all three of those. Now we can certainly do this as we're going, or you could write a second step. Let's just do it as we're going. So I don't have a cube. Let's see, I do. I have 14x cubed minus 6x cubed. It's going to give me 8x cubed. Okay. So done with that one, done with that one. Let's work on the x squareds. 8x squared minus 4x squared gives me 4x squared. Okay, great, done with that one. I don't have a single x in the second one, so that's just plus 4x. And then 2 minus a negative 7 would be 2 plus 7, or 9. Okay, yay. Moving on along, now we've got multiplication. And so I'm going to need to, this is the way that I would like to do it. You can certainly multiply in whatever order you want to, but we just need to end up with the same answer. I'm going to take the first term and multiply it by all the terms in the second. So I've got a binomial times a trinomial, just practicing our vocabulary. So 2x times 3x squared is 6x cubed. 2x times x is 2x squared. 2x times a negative 3 is negative 6x. Okay, great. So now let's work on the negative 7. I'll move this down just a bit. Okay, so now I'm going to take the negative 7 and distribute this way. Okay, so negative 7 times 3x squared is negative 21x squared. Negative 7 times x is negative 7x. Negative 7 times negative 3 is a positive 21. Whew, okay. So now combining like terms, we'll finish this little guy up. 6x cubed. Let's see, 2x squared minus 21x squared is negative 19x squared. Negative 6x minus 7x, negative 13x, and then plus 21. All right, not too bad. Okay, this one is a little crazy. I'm not going to lie. 2x plus 9 cubed. Please, there is no distributing this over. That is not a thing. This means that I have 2x plus 9 times 2x plus 9 times 2x plus 9. Yes, that is what it means. So what would we do? Not cry. Okay, we're not going to cry. We're just going to work it through. So let's FOIL the first two together. So I have 4x squared plus 18x plus 18x. 9 times 9 is 81. Okay, got that. And that's times 2x plus 9. So let's clean up that stuff in there. Let's add the 18s together. So 4x squared plus, let's see, 18 and 18 is 36, plus 81 times 2x plus 9. All right, then there would be a lot going on, right? Because we have to do, okay, do this one times this one. Then we'd have to do that one times that one. Then we'd have to do this one times this one. Whew, just for time's sake, I'm going to give you the answer and let you do, that would be fun, right? Just kind of work that out, see how that goes. This is what you should get when you're done with all that super fun multiplying and combining like terms. This is what your final answer should be. Whew, that's intense. Some big numbers. You're probably thinking, oh my gosh, that'd be a great test question. I'm just teasing. Okay. All right, let's move to, oh, this is what your answer would be. Yes. Let's move to number 5. Okay, now we do have three things to multiply. Again, it's not, we're going to have to FOIL and then FOIL again. So I'm going to work on the first two, doing this. So I've got 8x squared minus 4x plus 10x minus 5. Let's combine like terms inside there so our work is a little easier. Okay. Now we're going to distribute all of those. All right, we can do this. So we've got 24x cubed plus 18x squared minus 15x. And there's that one. Way easier than that other one, huh? Ooh, that other one was crazy. Number 6. Now we're dealing with multiple variables, which can get a little crazy. But again, we just are going to do our distributing. So we multiply the common items together, like 3 times 4 is 12, we know that. And a times a is a squared. And there isn't a b to multiply by, so b times 1 or b. And now let's do the other one. 3 times negative 5 is negative 15. A times 1 is a. B times b is b squared. Okay, made it through the first one. Let's try the second one. Okay, so 4 times 2 is 8. And b squared and a squared are different, so b squared times 1 is b squared. A squared times 1 is a squared. Then 4b squared times 1 is just delightfully 4b squared. And if we can combine like terms, we would, but none of those variables match. The first one has an a squared b, the second one has an ab squared. Then we've got the b squared a squared and b squared. That just sounds crazy, doesn't it? We don't have any way to add those together, and you're probably really glad about that. And that's the answer. Last question. Write the figure's volume as a polynomial in standard form. Well, okay, that's nice. They even gave us a formula for volume. Yay! So volume is going to be length, which is 3x plus 1, times width, which is x, times height, which is x plus 3. And they want it in, yes, standard form. Not factored form, it's in factored form. Wouldn't that have been nice if they said they wanted in factored form? But no, they want standard form, which means we get to multiply. Yay! So we're going to multiply these together, and that gives us 3x squared plus x. Okay, so I multiplied the, okay, let's work on our vocabulary. Binomial times a monomial, got that done. Now I need to do a binomial times a binomial, which is FOILing. So let's do that. So we're going to take the first one to both in the back, and then just our normal FOILing. So here we go. So I've got 3x cubed plus 9x squared plus x squared plus 3x. Let's see, we can combine some like terms. So 3x cubed plus 10x squared plus 3x. Whew! And there is our lesson on polynomials.